Hi calculus students, this video is on a new derivative rule called the product rule. And the product rule is how we can find the derivative of a function. Say we have some function f of x that is actually the multiplication of two different functions. So something like f of x equals g of x times h of x. So it is not true that f prime of x it's not as simple as just saying f prime of x, g prime of x times h prime of x. That doesn't work. That's not going to be correct. So what it actually is, we get f prime of x will be the first function, g of x, times the derivative of the second function, plus now I'm going to take the derivative of the first function times the second function. Okay, and this would be my product rule. So let's look at some examples. So my first example is going to be f of x equals x squared, that's a 2, plus 3, times x squared minus 4x. So the product rule tells us, okay, let me call one of these functions g, and one of these functions h. So let's say this is g and this is h. And I'm going to do like a little sidebar, or let me see what is the derivative of each of these things. Well, g is x squared plus 3, so g prime is 2x, and the derivative of 3 is 0, so it's just 2x. And then h would be x squared minus 4x, so h prime is 2x minus 4. Okay, so now that I've kind of set all this up, now I need to plug these values into this formula. So I could say f prime of x equals, okay, g times h prime, so that is this one times that one. So x squared plus 3 times 2x minus 4. That takes care of g times h prime. Now I need to do plus, right? Now I need to write g prime, 2x, times h, x squared minus 4x. Okay, so now that's really all the product rule is telling us to do. So this is g prime, this is h. Notice there's not a specific order I necessarily need to do these two products in. I could have done this one first and then this one. I also could have within each switched the ordering, so I could have written this first and then that, or vice versa. So depending on how tedious the simplification is, sometimes we'll want to simplify this further, and sometimes we'll just say, let's just leave it the way it is, because I don't feel like dealing with kind of some nasty simplification. For this one, it's not so bad, so I could actually FOIL this out and get x squared times 2x is 2x to the third, x squared times negative 4 is negative 4x squared, 3 times 2x is 6x, 3 times negative 4 is negative 12. So I can kind of like get all my terms here, and here I just need to distribute 2x in. So it'd be plus 2x to the third minus 8x squared, right? And now from there I could see, do I have any like terms that I can combine? So I have my x cubed terms and my x squared terms. So I would end up with 4x cubed minus 12x squared plus 6x minus 12. And that would be a more simplified version of the derivative. Okay. A quick note about this is I could have FOILed first here and gotten a sum of terms and then taken the derivative, and I should get the same thing. So let's just check that. So I'm starting with x squared plus 3 times x squared minus 4x. If I FOIL, this becomes x to the fourth minus 4x to the third plus 3x squared minus 12x, right? From here, this is still f of x. I haven't taken any derivative yet. So now what I want to do is take the derivative of this, and now it's just, there is no product here, it's just sums and differences, and then it's just power rules and constant multiple rules. So I would get, okay, x to the fourth becomes 4x to the third, negative 4x to the third becomes negative 12x squared, this becomes 6x, and this becomes minus 12. Now notice, if we compare what we got here to what we got here, they are the same. Okay, so one thing you're going to want to think about is when you recognize you have a product, you're going to need to make a call like, do I want to FOIL first and then do the sum and difference rule, or do I think I want to do the product rule? And there's going to be situations in which it makes sense to FOIL first. It's going to be easier and quicker to FOIL first. There's going to be other situations where I don't want to FOIL first. It's going to take me a lot longer, or not even be possible, depending on what type of function I might have. So let's look at another example. So for this example, I'm going to do g of x equals the square root of x times 1 minus x squared. Oh, can't see what I'm doing. Okay. So again, I need to say what are the two kind of h and g functions, and again, I'm like starting with a g, so it doesn't really matter what I call this, but I'll say g and h again. So this g note is different than that g, but for my sidebar then, g is the square root of x and h is 1 minus x squared. So the derivative of the square root of x, well, that's the same thing as x to the 1/2. So g prime is 1/2 x to the negative 1/2. And h prime is derivative of 1 is 0. And then the derivative of negative x squared is negative 2x. So now, putting this all together, I get, for this g of x prime, it should be this times this, and then this times this, right? So I'm going to write the square root of x times negative 2x. And then I would write plus 1/2 x to the negative 1/2 times 1 minus x squared. Okay, and this is something that kind of looks kind of messy, but I still could think about simplifying this a little bit further. So I could say, I could actually combine the square root of x with negative 2x to the first power, because I could think about this as x to the 1/2 and this as x to the first. So I can actually add those exponents together, and I would get negative 2x to the 3/2, because 1 plus 1/2 is 3/2. And then here I could distribute this in, and I would get 1/2 x to the negative 1/2 times 1, so it's just the same thing, and then this thing times x squared. So again, I would add my exponents and get minus 1/2 x to the, well, that's actually going to be 3/2 as well, because I'm subtracting 1/2 from 2. And from here, I would get, let's see, can I do anything else? Yes, I can, because I have two terms with x to the 3/2 in it. So this would be like negative 2x to the 3/2 minus 1/2 x to the 3/2. So I just have to add these two coefficients. So I would get like negative 2.5, or I could write it as negative 5/2 x to the 3/2 plus 1/2 x to the negative 1/2. And I could leave my answer like that. So I'm going to leave you with a U-try problem. So if f of x equals, we'll say 3x to the 5th minus 7x, and times, we'll say x squared minus 2x minus 7, can you find the derivative of this product? And I actually don't want you to FOIL. I want you to try to use the product rule and see what you get.